Right, first of all, I'm going to give a quick geometrical proof of why Pythagoras' theorem is actually true. So again, we'll draw some right-angled triangles. I should be getting good at drawing these by now. I don't seem to be. So we have A, B, and C. What does Pythagoras' theorem say? It just says that if I square the lengths of the smaller two sides of the right-angled triangle, I'll get the square of the length of the hypotenuse, right? So A squared plus B squared equals C squared, as kids are taught to chant in classrooms and whatnot. What we want to actually do is provide some insight into why this might be true. And the proof is actually quite nice. Draw a big box here. And I'm going to draw the same big box beside it. Okay, or at least attempt to. And I'm going to put 4 right-angled triangles in these boxes and arrange them in some fashion. You might try this at home. At home. Because, you know, you can do it on paper and get a much more real feel for this. Right, so these triangles that I'm labeling here, what I'm gonna do is, the shorter side I'm gonna call A. Notice these are all right angled triangles. A, B, A, B, A, B, A, B, right? And then similarly, it's the same triangles over here, right? The short side was listed here. Yeah, and they're all right angled. Okay, now let me just shade in those triangles and see what regions of the square are left. Okay, now these are the same square. We can see that because the big length of this square is A plus B, right, on both squares. Just by reading it off there, the length is A plus B. Okay, whoopie-doo. Right, now what's left inside the square? Well, what's this square here? This is a square. In fact, it has area B times B, B squared. And this is a square with area A squared. And over here, we've got, well, what's this? There's right angles here. Why are there right angles here, you may say? Well, if you draw it, you'll see why it has to be, but also because, remember, this angle and this angle have to add to give 90, because all angles in a triangle add to 180. So if they had to give 90, then because this one here is the same angle as this one over here, these also add to give 90. Angles in a straight line are 180. So this must be a right angle. Therefore, this is a big square in the middle. Area C squared. Right. So, well, those squares, these two squares on the right, must sum to give that square on the left. So that's one reason why Pythagoras' theorem is true. Right, it's a pretty nice geometrical explanation of why in a right angled triangle you have A squared plus B squared is C squared.